Dear friends, today we are going to learn about the calculation or determine the centroid for simple plane figures using first principles, that is integration method. And in addition to that, we are also going to see the graphical methods, how to do that for discrete figures. In the earlier session, we discussed about the need and applications of centroid. So in that needs, we are specified that in order to identify the center of mass and center of gravity, the centroid is helpful tool for the uniform solids and uniform gravitational field conditions. Hence, the application of centroid is useful for the determination of the moment of inertia and understanding the tilting of the moving vehicles with the position of the centroid or center of mass. So it is evident that centroid plays a major role in the design of the basic figures in the automobile field and even in the satellites also. So while for the determination of the centroid, we came across the four methods. That is, first one is from first principles, nothing but integration method, and second one is method of moments, third one is graphical method, fourth one experimental method. So the first method is from first principles. In the earlier session we have seen what is the principle of it, how to do that. So we will recapping the same a little bit. If the total area has been capital A has been denoted here. So in the total area, we are considering only a small part dA. We are considering only a small part dA. That dA has to be a representation of the whole area. Hence, in order to get the whole area from the small differential element area, we need to integrate. That is nothing but summation. So for the summation, A is equal to integration of dA. In the similar manner, to get the moment of an area, we require to multiply the area with respect to the perpendicular distance. So for each differential element area is to be multiplied its corresponding direction of the coordinate axis perpendicular distance. So if I consider qx, that is the first moment of an area about x-axis qx, then it should be multiplied its perpendicular distance y. This is the perpendicular distance from this point to this point. So y integral of dA, it gives the qx value. After obtaining the integral moment of an area, if we divided the same with the entire area, it will gives the y bar. So the formulas are obtained in the similar manner. In order to obtain the x bar, you need to obtain the first moment of an area about y-axis. In order to obtain the y bar, that is centroid about the y-axis, that is x-axis, the distance y bar, it is required to moment of area about the x-axis. So this type of integration and then division with the area is known as the first form principle of moments. So the same thing has been we are calculated for the rectangular case. So in this example, we are going to see that x bar, how to calculate from the using a first principle. So for the x bar, we require to take the moment of an area about the y axis. Therefore, y axis is this one, and so qy has been taken integration. So this is the procedure we have to follow for the same thing. So qx is equal integral of y dA. dA is a small differential element, hence it is multiplied with the width b from this point to this point and its height dy. Therefore it will be b dy. And similarly, after limiting the boundaries, that is 0 to h, because this differential element can travel from the 0 point from this point to up to highest point h up to this point. It can move to down and it can move to the upper side. So this is the summation we are taken, hence it will be 0 to h. After solving, the qx value is bh square by 2, and you also know that area of the rectangle is bh, then divided you got y bar is equal to h by 2. So similarly you can solve the x bar. So this is the x bar, the same procedure we are calculating the x bar as b by 2. Today in this session we are extending the same thing, that is determination of centroid for simple plane figures from first principles and graphical method. So in extension of the first principle, we are going to calculate the centroid of a isosceles triangle. So please note that we are determining the isosceles triangle centroid. So this formula is not applicable for all the triangles. This has been especially for isosceles triangle. Right? So for that, same procedure we have to adapt. Take a strip or differential elemental area, that is dy. So take the dy, and this width is not equal to the b. So at this portion, this width is very lesser, which is lesser than the b. If this elemental strip, if I consider here, it will be equals to b, and if I consider here the b is 0 at this point, please note that at this point to b equal to 0, whereas at this point at the bottom b is equal to b. So this elemental strip is traveling from b equal to b to b equal to 0. So hence its width is not constant, its width x is going to be vary. So how it is going to be vary, that has to be, we have to notice how to varying it. For that we need to take a simple concept of similar triangles. From similar triangles, you please observe, in this one there are two triangles. One is a big triangle, right? And second one is from the differential element area where you are considering, that is the small. So if you see that this is the x and this one is b. This one is B. And this total height is H. This total height is H. Whereas for this height is H minus Y, where it is given, right? So hence this part is, if I can say, this part is X and this is H minus Y. So this portion is H minus Y. So simply it can be written as H minus Y. So I need to consider this one. So for the similar triangle concept, so this is the big triangle, this is the big triangle B and H, and this small triangle, this one is the small triangle, right? So I need to take the similar ratios. Therefore B by H is equal to X by H minus Y. So B by H equal to X divided by H minus Y. So in this all the quantities X is varying one, hence I taken that one side and remaining all on other side. Therefore X equal to B into H minus Y whole divided by H. So after obtaining the X value, now the to determine the centroid of the isosceles triangle, Qx is equal to y integral of dA. Then substitute what is the dA? dA for the differential element x into dy. For the differential element x into dy. Then integrate with respect to limitations of 0 to h and substitute the value of x from 1. So this x value has to be replaced with the from 1. So then replace this one x value and then substitute the limitations, then solve it. So in this equation it is bh by h, that means hh will be cancelled for the first term, then b into y is the only leftover figure. Then integration of y equals to y square by 2, and for the minus term that it will be y square by h. Hence after integration it will gives the y cube by 3h. Then apply the y limits 0 to h. There you are obtaining the simplification. So after applying y is replaced with the h, then h square by 2, then h cube by h. So h is going to be cancelled here and you will get h square. So h square by 2, h square by 3. Then solve this one. Bh square by 6 is the first moment of area about y-axis, that is qx. Then y bar is equal to qx by a, that is equal to bh square by 6 divided by area of isosceles triangle is of bh. Then you are obtaining y bar is equal to h by 3. So this is the way you need to solve using the your integral method. So the same thing has been represented as h by 3. So this is the point where the your centroid about the parallel to the y-axis has been located. To obtain the x bar, By inspection also you can understood that being it is isosceles triangle, it has a symmetry. Because it is an isosceles triangle, it has symmetry. So use that symmetry principle. By inspection you can obtain that this entire distance is capital B, hence it is due to the symmetry it will be B by 2 from the origin line. So if I take this is an origin, so this is B by 2. Now x bar is equal to B by 2 and y bar is equal to h by 3. Then show the same values in the isosceles triangle, taking the left and bottommost corner as your origin. So this is the values B by 2 and h by 3. Now the same similar procedure can also be extended to find the centroid of a circle. For to find the centroid of a circle, it is you can by inspection you can say that there is two symmetrical axes are there. You can observe this is the one of the symmetrical axis and this one is second symmetrical axis. The centroid properties is saying that if any shape has two symmetrical axes, the centroid will locate its intersection. So this is the intersection point. So this intersection is gives you centroid point. Obviously, it is the distance of radius only. If I can figure out it, so this might be radius, and this distance is also radius. So without any further integration process, you can by inspection you can say that the centroid of a circle is r, that is radius r, half of the diameter from the left and bottommost points. That means this is the left axis and the bottom axis is this one. So from this point it is r is the radius, that is the centroid x bar, and r is the radius towards the y bar. Therefore for the circle centroid is equal to from the origin point, that is out of the figure, left and bottommost origin point, then it is the radius or half of the diameter. This has been obtained by inspection of the symmetrical axis. But it sometimes if we are interested to know about the using the first principle, how to find out the centroid of a circle. It takes a several steps and some integration procedure which you need to be apply your mathematical skills. Let assume a strip of height dy. So this one height is the dy. From this point to this point of the strip is height dy. Having an elemental area 2x dy. You see, so now I am taking an axis. Please, my reference axis is at the center. Reference axis is at the center of circle. That is 4. So please mind it. So I am entire procedure is based on this assumption. That is my references axis, either it is x-axis or y-axis, both are originating at the center, not at this point. I am not considering this point. This is the outermost point. I am not considering this point. So what I am considering? I am considering the center of the circle. So Hence, this is the our our center, right? So we are considering this as a center. So now, in order to measure the length of the or width of the this differential element area, I need to take the both the sides of the axis. So this is the one side of the axis distance, this is another side of the axis distance. So one side it is a minus x, or other side is positive x, but we are not algebraic summing the distance. In order to obtain the distance, we need to mod of the distances. Hence, we are not taking any sign of the distances. Hence, we are simply adding the x plus x, that is 2x. Hence, we are using the term 2x. Therefore, 2x and the elemental area is equal to 2x into dy, multiply with the height. Therefore, 2x into dy is the elemental area. And here the unknown is x. In order to find the x value, we need to use the one of the simplest properties of a circle. So that is the basic property of a circle is radius square is equal to x square plus y square. So use the same equation to obtain the x value wherever it is there. How it is came? You can simply say that this is the actually this is the radius. I can say this is the radius. So this radius square is equal to y square. This is the y, and this is the x square. Or you can say this is the y and this one is the x square. So the same principle has been used here. So r square is equal to y square plus x square. From this, we are obtaining the value of the x equal to square root of r square minus y square. So we know that the area of the differential element is 2x dy, and to know the centroid we required first moment of an area. Therefore qx is equal to y integral of dA or integral of y dA. Then substitute the value of dA in the first moment of area. Then it will become integral of y 2x dy. Replace the x value with the equation 1. Then it will become 2y, then square root of r square minus y square, then dy. Its limits will be, you can see that I have taken this as a zero origin point because I am taking center of the circle as my reference point. Hence, this is the bifurcation axis of the lower side is a negative, and upper side of this 0 0 axis it is positive. Therefore, what is the distance of the extreme points from this point to this point? It is a positive r. So I can say that here it is a positive r, and this point up to this point you can say this uh, negative r. So up to this point it is a negative r, up to this point it is a positive r, and this one is zero line. So integration limits are from minus r to plus r, minus r to plus r. Then use this equation to solve the qx value. So in order to solve this, it having the square root. So it is difficulty to solve the same thing. Hence, in an integration process, we have some shortcuts to solve it. Hence, the square root of r square minus y square has been solved like this, assuming that r square minus y square is equal to t square. It is an assumption to solve the integral. and differentiate on both sides because I need to replace the dy in terms of the dt, because you can see here it is the dy. So dy is when I am replacing r square minus y square as a t square, then dy is also be replaced. For that, I require to differentiate this equation that is assumed. Therefore, after differentiating on the both sides, so differentiate on both sides, you obtain that being r is a constant, minus 2y dy is equal to 2t dt. That is the you are obtained. So the same thing is need to be substitute in the earlier equation. What is your earlier equation? This one. So substitute dy value and r square minus y square as a t square. So you are getting like this. So you can see that 2y 2y and dy is equal to how much? 2t dt. And so the same thing has been replaced, it is as 2t dt, and it is the minus sign here, hence the same thing has been given as minus sign here. So this is equivalent to the 2y dy, right? 2y dy is equal to minus 2t dt, minus 2t dt. And now what about the square root of r square and this r square and minus y square is equal to t square. Substitute within the square root of t square, then you got it as a t. So this is the t. So this should be equal to t. So after substituting of this one, then differentiate it, you are obtaining minus 2 into t cube by 3 as an integration, as an integral value. Then apply the limits. After replacing the t in terms of the r square and y square, which is assumed earlier, after replacing only you need to apply the limits, that is minus r to plus r. So solve this one, you will definitely get 0. That means qx is equal to 0. But you know that if qx is going to 0, then y bar is, if qx is equal to 0, then y bar is equal to 0, because y bar is equal to qx by a. Y bar is equal to qx by a. Area is not the 0, but qx is equal to 0. Hence, y bar is obviously equal to 0. Right? Similarly, if I take the strip in the vertical direction like this, if I take the strip in the vertical direction and solve for the same thing, and I will obtain the same value as x bar equal to 0. So for the centroid of a circle, if I take in the origin at the center, if I take in the origin or reference axis are at the center, then you got its value of the centroid are 0 comma 0, which is obviously true because the symmetrical axes are intersecting at 0 comma 0, right? In other words, if I take in the axes are outside of the circle object, that is leftest point and bottommost point as shown in this figure. So now my axes are shifted from the center to the its first coordinate side, so first quadrant side. So the entire object is now placed into the first quadrant. In that case, your Centroid in the x bar or y bar are equal to radius or d by 2. So it is equal to d by 2 or radius. So generally in the ESET point of view also, while they are asking about the centroid of a circle, you please observe that which reference they are asking, whether they are terming it as a first quadrant or they are making the references axis as a center. If the center of circles are the references axis, then your centroid is 0 comma 0. If the are asking at the left or bottommost or the origin of the normal quadrant axes, then the centroid of a circle is radius or half of the diameter. Now these are the some basic shapes of the, these are to be solved in the same manner. So this is the triangular area, which is not the isosceles, might not be the it is not a right angle triangle too. So in that cases, these are the values have been given for your reference. And here it is the x bar will be the need to be find out. Here it is not given the x bar is need to be find out. So there are different methods for this type of irregular figures, how to find out the x bar value, right? So this is the y bar value. And for the quarter circle area, this is the quarter circle area, right? This is the quarter circle area. For this, these are the values. And for the semicircular value, this one, these are the values. it, why it is 0 x bar? Because he is taken the origin of the axis at the center. If it is not that case, if he is taken the origin at this point, then it would be the r value. Then it is not the 0, right? It will be r value. But y is not going to change with respect to this axis, because y is height. Either you take up to this point or you take up to this point, the both value will be same. So the axis makes the sense. If the axis is at this, this is 0 is right. If the axis is at here, then it is not the 0. At that case, it should be the capital R. And semi-parabolic area, please refer the axis where they are coming. So here it is originating axis. This is the originating axis. That's why he is saying that this is x bar, right? Similarly for the y bar, right? Y bar axis is also from this side, from this side. So these shapes are important and their axes are important. In some figure, if this is not drawn like this, if this is drawn like this, let us say, the same figure can also be drawn in another manner. So the same figure can also be drawn like this. Now x bar value will going to be changed. Now it will be 5a by 8, because if it is the origin from this point origin, for this x bar is equal to 5a by 8, not the 3a by 8. So you please mind it, right? For shape, if I am changing the shapes like that, their origin axis. So similarly, for the parabolic spandrel also the same thing will be happen. Parabolic spandrel. So these values are sometimes in ESET point of view it is required, but in general cases of your academic importance, this parabolic area and semicircular area and semi-parabolic areas and quarter circular areas and triangular areas are the important for your academic point of view. And semicircular arcs of the circles. So these are the total x bar and y bar and areas are given for the different areas. This quarter circle area arcs are so important for you to get that. So please remember that this origin is going to be changed. Origin changes, then value is also be going to be changed. And triangular area in this particular case, this is the triangular area. It is a right angle triangle and origin is taken from this point. Please mind it. So origin is this one. Please, origin is this one. Hence, he is measuring from this origin as b by 3. From this origin h by 3. Right? So axis of origins are important to calculate the values. So if I asked if my origin is here, then what is the value of x bar? Then it is 2b by 3 because the total is b. Now if I am taking from this side, now it should be 2b by 3. Right? So remember that if my origin is like this, then 2b by 3. Then value is 2b by 3. And similarly, if I taken the quadratic circle, quarter circle area, the values are 4 r by 3 pi. These are repeated for your sake of further more interested and to enhance the same thing. And quarter elliptical areas. This area is not the like your parabolic like that. It is not. It is elliptical area. That means ellipse like that. And for the some other sectors and spandrels, arc of circles, these are external are important for your academic further enhancement of your knowledge. So refer these things, it will give the better idea. And the last topic of this session is finding the centroid using graphical method. The graphical method is generally adopted for irregular areas and where the much accuracy is not required. uh, that means if the time permits, it will gives the more accurate values. How much accurating you are going to calculate the areas of the segments, it depends the accuracy of the centroid. So it is important to draw the graphs on the graph sheet, that irregular surface, and obtain the areas of the segments in uh, accurate, then it will yields the your value of the centroid accurately. So for this you need to draw the graph of any irregular shape on the graph like this is the one of the shape we have, let us say. So the procedure is like this: divide the area into discrete elements, that is small parts. So you need to divide this entire area into small parts. So this is the, I am just for understanding I am taking more strips, bigger strips, but actually it would be lesser width should be taken as possible as to get the accurate values. Now after getting this one, now you need to calculate the areas of the each segment. So this is the segment 1, this is the segment 1, segment 2, segment 3, segment 4, segment 5, 6, 7, 8 like that. So for calculate the each areas, area 1 segment, area 2 segment, area 3, using the graphical on the drawing on the graph sheet you can obtain the areas, or by using the planimeters like that. Some surveying instruments are there to get the irregular areas value. So obtain these values and Mark these values at the center of the each segment as areas 1, area 2, areas 1 and areas 2. Then these areas have been, so these areas whatever you are obtained, these areas will be used as representation of each one as a A1, A2, A3 like. So each are having some values. A1, suppose A1 is A1 is equal to, suppose let us say A1 is equal to 300 mm square, right? Like similarly A2 equal to 450 square, A3 equal to 250 square. So draw the corresponding length of the A1, A2, A3 by taking a scale. Let us assume I am taking a scale of 1 mm is equal to 1 mm on the sheet is equal to 10 mm on the practical. So if I am taking this type of scale and draw the A1, A2, A3, right, as a collinear like this. I am showing the same thing how to draw this one. So please see that. So this is the shape. This you see that. So in this one, A is equal to 1 is to 10 scale of, that is 300 mm. So divided by 10, 30 mm. So this distance is 30 mm. And for the B, this distance is, we are taking 450, 400. So divided by 10, therefore it will be 40 mm. So draw A, B, C, D like that, all the areas A1, A2, A3 like that. And after that, they are to be added as a collinear forces or collinear areas like this one. So this AB length is equal to the A length, that is 30 mm, and BC length is equal to B length, that is 40 mm. Similarly, you can also draw the CD length, that is equivalent to the C value 25 mm. Then take some origin O. This is optional. You can take anywhere. Here also you can take. Here also you can take. Anywhere you can take this value and join all the parameters A to O like that, B to O, C to O, D to O, like that. Join all those things. Now AO is a, measure this AO and draw the same parallel line. Measure this AO and draw the same parallel line in the space of the A. So this is the space of the A, and so this parallel line is equal to this line. Just to draw, not with measure, not with the measurements. Just draw it. And similarly, BO is the BO is the line. Take the same parallel line here and draw here in the space of the B. This is the space of the B. And similarly for the C also, then draw all those things C. Now what you have to do, that to obtain the centroid, just extend all the rays. So whatever the forces, either it may be 100 numbers, whatever it may be, just extend those rays. Now A is extending in another direction and this one is also extending in other directions. Like that, all you have to extend. Their intersection point, their intersection point will give you the this intersection point is your resultant or your centroidal point. So that measure that distance from this A. So that is known as X bar, right? So this is the location of the centroid. These type of drawings are known as funicular polygon method or area polygon method. So here what these arrows are representing is scaled areas. Hence it is a area polygon. This is a area polygon and this one is funny funicular F polygon, funicular polygon. Hence, these by drawing these area polygon and funicular polygon, you can obtain the x bar value. And similarly, if you draw the horizontal lines of the areas, you get the y bar. So repeat the same procedure for the to get the y bar. So the procedure is explaining the same thing. Divide the area into discrete elements of the small parts. Calculate each segment's area and locate its centroid. Determine the line of action of the resultant by drawing the area polygon and funicular polygon. So to obtain the centroid. So repeat the same procedure for obtain centroid in other direction, right? For the y bar also. Right? So we are discussed about the funicular polygon, the diagram which is drawn to find the exact position of resultant or centroid in the space diagram or in the plane diagram is called funicular polygon. It is obtained from the rays of the polar diagram, that is nothing but area diagram or force diagram. What is the area diagram or force diagram or polar diagram? The diagram constructed from vector diagram. That's why we are taking a scale of the areas. Or if you are talking about the coplanar forces like that, then it's a vector diagram. Otherwise, for the areas, it is a scalar diagram. By selecting a suitable point as a pole, that is, we are choosing as a O, to which each point of vector diagram is connected is called a polar diagram. So using this funicular polygon method, you can obtain the resultants of a force system or you can obtain the centroids also. So geometric characteristics can also be determined. So similarly, and you can obtain the engineering, hydraulics, economics and other fields also it has its applications. So this is the forces for the to determine the force systems for the irregular shapes. You can also use this polar diagram and funicular diagram to obtain the resultants. So the same method is also used for to determine the centroid. So this is the procedure we are followed the same thing. So in that procedure we are drawn the polar diagram and funicular diagram to obtain the centroid. This is how the graphical method has to be solved to obtain to get the centroid. So in this session we are calculated the centroid from the first principles for isosceles triangle and circle. Similarly, we are also discussed the what are the different basic shapes and how to obtain the their using the integral methods. So graphical method is also be one of the part of finding the centroid methods. Hence, we are also discussed what is the polygon polar methods and funicular system to obtain the centroid. Thank you.